Thank you for joining us. The webinar will begin in 1 minute. Good morning, afternoon, or evening, depending on where you may be. Thank you for standing by, and welcome to today's Tivoli User Community webcast. Our topic for today is Go Tell It to the Frogs, the new amazing ways WAPL can help your workload. All phone lines are in a listen-only mode, and later there will be a question and answer session with further instructions being given at that time. You may ask a question at any time during the presentation using the chat window located in the control panel. Questions will be answered at the end of the presentation with the rest of the Q&A. Today's session is being recorded, and you will be provided a copy of today's materials following the call. Now I'd like to introduce our speakers for today. Dean Harrison reached many major milestones in 2015, 30 years experience as a TWS user, 10 years of working as a software developer, and now becoming the father of a brand new programming language, Workload Automation Programming Language for ZOS, or WAPL for short. Dean also has 10 years attending ASAP under his belt, and in this time, the frogs have remained around and SOE has grown into a bigger, better, more powerful beast in the name of WAPL. Mark Lazo has been a member of the production support team at Verisk Analytics, formerly Insurance Services Office, for almost 10 years. He has 7 years experience working with scheduler tools, providing application support on both distributed and mainframe batch processing, and had the pleasure of working directly with IBM SMPO teams starting May of 2014 and fully converting to TWSZ 9.2 in February 2015. Now I'd like to go ahead and turn it over to Dean.
Hello, everybody. My name's Dean Harrison, as you've just probably heard, and today I'm going to talk about what happened to SOE, which was often known as the Free Operational Rex Goodie Bag, or FROG, if you're wondering where the frogs came from. It was basically a little free tool that we provided that you could do some clever little things with, but it wasn't supported. Now we're going to have a look at what's happened to it in the last year or so and see the things it can do now before Mark's going to go and show you what he's already done with it. So, 2 sections. We're going to talk about the changes in the software, so the things that have been added in the last year or so, and then Mark will do his little bit. So let's get in there. So we're going to talk about the bad old days, and we're looking really here about this particular session today is going to look about how you can use WAPL to be an extra operator, if you like, help you monitor your workload and make some decisions. And before 2009, pretty much your only choice of tool to check up on anything was the list stat command, which is in the batch command interface tool, or BCIT. So what you did was you scheduled a job at a predefined time, and that would issue a return code specific to whatever status that job was in. So basically you could do some form of milestone alerting to tell you if a particular job wasn't in the status you wanted at a point in time. Now from 2009 we had SOE, and that had a version of list stat, but whereas BCIT had some rather cryptic return codes, with SOE you could actually choose what are good return codes and bad return codes and just make your job fail for a status that you wanted alerting about. But that was pretty much the way you got informed by a job failure. So your list stat job would fail to tell you, hey, this thing isn't in the state you want it to be at this time. And this job could only really check one job at a time as well. So if you wanted to check more than one thing, you had to run several list stats. 2011, we got a little extra trick going into SOE from version 3.1, and that was that list stat could actually issue an SR stat for selected status values. So we moved away from having to have a job fail, where we could actually have the list stat would check the status of something and make something else happen. So we could have something that maybe sent a message or sent an email or something like that. So it gave you a little bit of conditional reaction to the state of your workload. But it wasn't able to do everything maybe that you wanted. So 1 year on from SOE 3.3, which was the last official release of SOE, we went to WAPL with version 9.3 of what is now IBM Workload Scheduler for ZOS. And that got a whole new set of commands called current plan operation commands. And these things have a lot better search criteria to be able to identify jobs, and they could also select more than one job. So it could actually start to tell you things about a lot of jobs in one command. We also had things called object variables, which gave you detailed access to things in the plan. And the fact that this had gone from being a utility as SOE to a programming language meant you could now make decisions inside the code. So you could do lots of things all at once. When you find a particular status change, you're not restricted to doing one thing as well. You can take multiple actions at one single checkpoint. And we also added a couple of extra communication tools, so you could send messages by email or console messages straight out of your program, and equally you could send commands to the console. So you could even cancel a job if you wish. So let's have a look at some of these new features in a little more detail. So we've got the current plan operation commands. And over here in the cloud on the side, you can see all the different commands that you can do. Most of those will be fairly obvious as to what they're actually doing. I'll just point out that the kill command is the same as the kill command in the 5.3 panel in IWS. So it'll only kill distributed jobs. The alter command lets you do almost anything to an operation, and then the rest of these things are fairly self-explanatory. They'll just do whatever it is that they want to do. Each of these commands use exactly the same keywords to find the jobs that you want, so you can filter on application name, job name, workstation, what statuses you're looking for, and it'll come back and find the jobs for you. And we've also got a special command called the find command, which uses again the same criteria to be able to identify jobs in the current plan, but doesn't do anything. So it just produces a list that then in your code you can decide what actions you want to do with the things that it found. So it gives you the flexibility then to decide exactly what it is you want to do and find exactly the scope of operations in the current plan that match what you want to check at that time. So how do you find one? Well, for those that understand PIF or have maybe used SOE before or BCIT, there's a list command for CPOpcom, which is basically an operation in the plan. So any of the arguments you could use for those, you can use here in the current plan operation commands. So again, application ID, input arrival, operation number, job name, etc. You can specify as many of these criteria as you like for efficiency of execution, and you can also use a list of statuses. So you're not just restricted to finding all jobs in a started state or all jobs in a waiting state. You could pick maybe arriving, ready, started, waiting, all as a list. There are also filter keywords that after it's got the list of operations out of the current plan, it will whittle that down to a smaller list of operations. So you can specify a range of input arrival date and times, so you only look in a particular window. You can say how many that you want to actually return. So you could say find me all the jobs beginning with ABC, but count by default will only select the first one it finds. If you put 0, it'll select all of them and you'll get the full list of all of them in your plan. But typically, again, going back to the list stat ID, you most likely want the earliest occurrence of the thing that you're looking for. But if you don't want the earliest, maybe latest, then the position keyword also lets you say, well, take the latest one off the list or the earliest one off the list, or the earliest 2 or 3 or 4 off the list. By changing the count number, you can say exactly how many you want to grab the information for. So once you've got them in a command, what do you do with them? Well, we saw the find command on the little cloud on the earlier slide, but there were lots of other commands as well. And what if you want to run a whole set of commands against a set of operations, but one of those commands might in some way change the operation, so the arguments would not find it in the next command. So you may be looking for things in a particular status. The first command alters the status of the operation, so the next command maybe wouldn't find all of the things that the first command found. Probably doesn't make much sense without seeing an example. Hopefully, Mark will show you some of those later. But what we can do is we can find everything and then save the list of things using the save list keyword. Then all the following commands can use useList to say, do this to the same list of jobs that the previous command ran with. You can also create something called an object variable. Now, a lot of programmers will understand what an object variable is straight away, but a lot of scheduling people might think, what on earth is this? And I suspect this will be one of the features that it will take some time for people to get used to. But the idea of an object variable is it contains the list of absolutely everything about all of the things that were found in the command. So, for example, we could have the list of operations, and from the object variable we could find its operation number, its input arrival, its JES number, what the submit flag was set to, what the time dependency flag was set to. All of that information is available. And these object variables are essentially a list with lots of properties. They can be used to store the contents of files. They can be multi-dimensional for things like applications. And at the lowest level, the basic PIF list, select, and read commands will generate object variables, but also all of the new current plan operation commands will generate them. Like I say, don't worry if you don't understand them in the scope of this presentation. When you start to see examples of them and start to play with them, they'll start to make a little bit more sense. But for your information, these object variables all begin with the exclamation mark and an at the beginning of the name. So they do stick out in the code rather clearly, so you can see you have an object variable. Now, I mentioned that an object variable was a complex multi-dimensional thing, and the chances of you being able to remember the names of all the different properties that any type of object in TWS might have is fairly slim. So there's a command called show object, and you just issue the WAPL command show object and name the type of object you're interested in, and it will give you output looking like this that will show you at the high level all the high level information you can get. So here, for example, this would be an application in the database, and we can see that whatever my object variable was, if it was at obg-adid, that will give me the application name. adcal on the end would give me the calendar. But equally, because an application is a complex object in itself, over there on the right-hand side, you see at obg-pound-ad-run, that property tells me how many run cycles I have, and then in my code I can step through slightly more complex variables that tell me the run cycle's description, what type of run cycle it is, and so on. Every piece of information you can get at, and this show object command will tell you the format of the variable that you need to refer to in your WAPL code. It's now a programming language. It basically changed in the middle of somewhere in 2014, we actually added if, then, and else into what was originally going to be SOE 3.4, but then ended up becoming workload automation programming language because it really had changed so much from what SOE was. So now, with if, then, and else processing, we can make our checkpoints actually react to a list stat result. So if you issued a list stat command, you can then make different decisions based on what return code you get back right there in the code. We also have do processing, so you can do until, do while. You can even do forever if you're feeling particularly brave. And WAPL does have loop protection built into it. So if you did have a runaway do loop, it will cancel itself, I think, after 1,000 runs around the loop. But the do process allows you to do multiple things at once. So if a particular command returns 5 jobs, you can, in the do loop processing, do the same thing to each one of those 5 jobs in a loop. If you're an experienced Rex programmer, then you can use Rex functions in the code. So anywhere where you've got an if, then, else, or a do loop or whatever, you can put Rex functionality in there to help set your variables or help with the if, then processing. And this is actual Rex that's being called under the covers inside WAPL. So it gives you quite a rich scope of things that you can do now in the programming language. And I rather like it because I didn't have to write all that code. We just used the one that was in Rex. But the main thing, the big thing, and I think the thing that Mark was really happy with, was this version finally had the ability to be able to talk to the outside world. So we had a new send mail command, and that uses SMTP to send emails direct from WAPL. Now, SMTP is something that you implement on the mainframe as part of your TCP/IP setup. If you haven't got SMTP implemented, then WAPL can't send emails. So it's dependent on SMTP being implemented on your system. But the email text can then include variables, and you can even include files for any variable length content. So you could write, in your WAPL process, you could write data into a file, and then you could include that file in amongst the text of your email. Just be aware at the moment it doesn't do attachments, it will just include the file inside the text as clear text. We've also got a send message command, and this will just issue a console message, which in turn you can then use your own automation product, whatever that may be, to trigger some automated processes. So your WAPL code can go away, find out something that needs to be done, and then hand that off to an automation tool, which maybe, for example, raises a trouble ticket. So maybe you can have a situation where a job doesn't fail, but you can still issue a prompt to your automation to raise something in your problem management system. We also have a new console command, and this will allow commands to be issued to ZOS or JES. It's a very primitive console command. It will detect if you've issued a bad command, but it doesn't get any other feedback. It can't tell you whether the command actually worked or not. But its core purpose is that you can actually use variables in the command. So you can grab data from the current plan and issue a command to ZOS or JES directly from WAPL. This is all subject to RACF security as well, so you have to enable the user ID that the WAPL process is running under to be able to use extended consoles and issue those console commands. So this isn't a way of getting around security. In fact, to actually get this to work, you have to implement a lot of RACF rules to make it be able to happen. So that's the new stuff that I added. A lot of it directly actually at Mark's request for the work we were doing on their migration. So I believe right now we're going to have a quick poll question before handing over to Mark to show you it in actual use.
Okay, thank you very much. All right, so our quick poll. Do you think you have a need for WAPL at your site? So please select one. Yes, I have a need. Not sure. or I don't think I have a need. And we'll give everyone a few seconds here to go ahead and get their votes in. Okay, about another 10 seconds or so. All right, so do you think you have a need for WAPL at your site? 70%, yes, I have a need. And 30% are not sure. 0% don't think that they have a need at all.
That's nice to know.
Okay, Mark, I've made you presenter.
Okay, thank you. Good morning, everybody. My name is Mark Lazo. In this section 2, as Dean pointed out, we're going to be talking about putting the WAPL in real use. I'm going to show you some examples and talk about how we have it implemented in our environment. And as Dean mentioned before, we kind of got into WAPL during our migration, and it was integral to the success of it, because it almost seemed like he was creating stuff for us on the fly, which obviously he was, but the things that are available in the latest version of WAPL now, you'll see in the next few slides. We have multiple applications for them, and
Mark, I'm sorry to interrupt.
Sure.
We're not seeing your screen. Can you go ahead and take a look and see if you can click share screen there?
I didn't get the. Let me see. Can you try one more time? I didn't get the request to share.
All right, let me swap back here, and I'll go back.
I've got to show my screen right now.
Yeah, I just switched it so I could go back.
Oh, okay.
Mark, sorry about that. Here we go. Okay, do you have the pop-up now?
There we go.
Perfect, thank you.
Okay, sorry about that. So before I continue, again, as I mentioned, we kind of got into WAPL in general, and had a really cool time because it was basically evolving as we were migrating. So, and again, you'll see some of that in the slides that I have coming up next. So, just to give you a little sneak peek into our environment, because it might give you some insight on if you have a similar type of environment, or if you're looking to migrate to the environment that we have, at least it'll give you an idea of how it can fit. So currently we run the end-to-end with AWS ZOS 9.2. We use eccentric agents for our distributed workload. We fully converted to AWS, as was mentioned before, from CA7 back in February. And the current version of WAPL that we have right now is build 0516. So again, just a little background for anybody wondering. So let's go ahead and jump right in. So the topics I'm going to cover, and some examples you're going to see, Dean went over in some detail the list stat command. Obviously, it's been around for a while, but now the list stat command is flexible enough where you can use some if-then logic and take action based on the status of a job. And as you'll see there, this is basically any status that can be returned by a job, A, C, D, E, I, so on and so forth. You can have if-then logic perform a multiple selection of commands, where needed, and that if-then logic again adds to the flexibility. The find command, Dean also spoke about that. Finding a listing operations in the current plan, depending on the size of your environment. If you needed to query the database to get X amount of jobs, WAPL now has the ability to find all that information for you. And he also spoke about objects, setting whatever details that you get from the find command, you can set them to objects to be passed down for the list, whatever list is created, or if you wanted to use the objects to, again, use if-then logic to take action based on what the find command comes up with. So you'll see an example of that. We also use it for dynamic submission. Dynamic submission is how we run a lot of our distributed workload. Instead of using the traditional run cycles with the every option, we found it a little more efficient in a sense to use the dynamic submission feature with WAPL because it allows for it actually creates a self-managing application, and I'll go into detail with what that means. But it ensures continuous processing when a job's in error, no need for operator intervention. And also with dynamic submission, what it does, and again, think about a repeat cycle. If you have 50 jobs that run every 5 minutes, instead of having that whole list of jobs waiting in the plan, if you use dynamic submission, only the next interval will come in, and WAPL is what controls that. So that's another thing that may benefit your current environment. WAPL also has the ability to do a JS start, and a JS start is simply the ability to pre-stage JCL. That was something that we actually needed to do during our migration. We have some processes that required this type of functionality, so we're going to show an example of the JS start. We also use it to do basic utility functions. You can use WAPL to back up your databases, the application database, operator instruction, workstation, whatever you guys need to get backed up. You can use WAPL to do that, and you can store that in case you needed to reload the database if it was corrupted or if you're migrating, whatever the case may be. And you can use the same proc, obviously the WAPL proc, to unload and reload that. And I don't know if I have an actual example of that, but we'll see in the next slide. And then the last thing I'm going to talk about, which was something that I think is what shines as far as WAPL is concerned, is what I call global flexibility. And that's the ability for the actual code itself to use variables that are listed in the user fields for your operation. Again, what this will basically do is it'll allow you to have generic code, so to speak, and all your tailoring can be done inside of each individual operation. So, not all operations you want reacting the same way, but at least this gives you the ability to, again, customize your environment for whatever operations that you need to have this type of control over. So here's your first example of the list stat. And I have 3 different scenarios here that I'm going to go over. So the first scenario is if you want to check if a job is on time. I think that's pretty simple. Business areas want to know if something's late. Operators want to know if something's late, whatever the case may be. If the job's not on time, send an alert to the people who need to know. The second scenario is some people want to know if a job fails immediately. I know that a lot of environments have ticketing systems, so if a job fails, tickets generated, but not a lot of times that information gets to maybe the business area or development. So now with WAPL and the send mail option, you can basically send an alert to anyone who needs to get it, using the send mail feature. And then you can also alter the status to see, which is something that I'll go over too. And the third scenario is you want to check if a job is running longer than it should. A lot of times you have a process that usually takes 5 minutes, and if it runs more than 5 minutes, then that's an indication of a problem. Not a lot of times something like that's being monitored. So, you can use WAPL to check the status of a job if it's running longer than it should, and you can also kill the operation, as Dee mentioned earlier. Again, this is only referring to open system jobs. And then you can alter the status to see, and again, we'll see an example of that. And basically, the code here, it all begins with the list stat. In this particular example, you see that the list stat command I'm using here, the application ID is test app 1118x. The original presentation was 1118, so sorry for that little bit of confusion. And then he also mentioned that in order for WAPL to run as efficiently as possible, you also want to include as much detail for whatever operation that you want to take action on in the list stat command to increase its efficiency, and also to make sure that it takes action on the correct job. So The workstation ID here is highlighted, operation number 5. The job name is going to be Opera0001. And here's where the list stat comes into play, and it sets a return code based on whatever the status it finds. So if we're going to do a list stat on operation 0001, if the status is an E, we're going to give a return code of a 99. This is inside of the WAPL interpreter. If the job is still running, it's going to be an S status. We're going to give that an 8, complete or suppressed by condition 0. And then the last value here, 4, is if it's a status that isn't defined here in the policy, it's going to give it a return code 4. So again, we're only looking for E, S, C, X. And just to give you some insight as to the kind of application, it's a very simple application, one operation. This is based on a single operation with a conditional dependency. I don't know how many of you are using conditional dependencies, but a conditional dependency in use in conjunction with WAPL, I mean, it just increases its effectiveness, in my opinion, because you can have the WAPL job run regardless if the job is complete or an error or it gives a specific return code. I don't know if anyone else is using conditional dependencies, but it just, again, it increases effectiveness. So here's the first scenario. My job needs to run by 10. Please let me know if it's not run. The simple way to do it is to schedule the WAPL job. Again, it's going to do a list stat. And because you can see here, the operation is going to start at 10 a.m. We have our WAPL job that's going to list the status of this job 1 minute after it starts. That's basically as close you can get is an alert to let either the operator or let somebody know that the job isn't started by 10 o'clock. So at 10:01, the list stat kicks in and it returns a code 4 based on a policy. The policy is if the job is in wait, it's going to give a return code 4. So here's where the if-then logic comes into play. So if the list stat command returns a 4 on that job, it's going to do the action based on this statement here. So if it returns a 4, which is what it did, it's going to send an email to the user 1 letting them know that, hello user, it's 10 o'clock, your job hasn't started yet. And as you can see here, this is an Outlook email for my testing. You'll see that at 10:01, if the job hasn't taken off yet, the user is going to get an email just like this. Here, the second scenario is if my job fails, which happens, a lot. Send me an email, and no further action is needed on the job. So as you can see here, we have the same application. The job starts at 10 a.m. The WAPL job has a conditional dependency to run, even if the job returns a status of E. So as you can see here, it's 10 o'clock. The job returns an error. The E status of the job, again, because we're using conditional dependency, it triggers off the WAPL job to take action on it. So based on the command here, if the list stat command returns 99, which is our policy is set when the status is an error, then do the following. We're going to send our email to the user, letting them know the operation failed, and then we're actually going to do a second command. We're also going to alter the status from E to a C. This is something that I think is extremely useful from an operator standpoint. Operators, in general, they'll also look at spend a lot of time in the error queue. So if we can streamline the way that these applications are controlled, where they don't have to be seeded out or cleared out of the error queue, WAPL can go ahead and do that for you. So again, in this case, because the job failed, we're going to send an email to the user letting them know, and then we're going to take a second action, and we're going to take a second action, and we're going to change, or we're going to alter the status of Opera 001 from an E to a C. And you can see that here. The WAPL kicked in, this job was an error, and now it's completed. And you see here the user is notified via email. Your job's an error. The error will be cleared from the queue. And the last scenario for the list stat, if the job runs for 5 minutes and if it runs for more than that, or if it runs for 30 minutes, then it's a pretty big issue. I'd like the job to be canceled immediately, and I also want to be alerted by an email. Here's where the kill command comes in. As you can see here, the job starts at 10 a.m. We have a hard-coded start time for the WAPL job to run at 10:30, because this is the point of no return, I'm going to say, because if it runs for 30 minutes, then there's a huge issue. So we're going to run our list at 10:30. And here is the command that will kick off because the job is still running at 10:30. So the 8 code is represented from the policy if the job returns a status of an S, which means that it's still active. So basically, if the job is still active, I want you to kill the application as outlined here, job name operole 1, status of S. I had to include the await here because WAPL is so quickly that a lot of times if you have a second command to issue on the same job, it might have be too quick, so I had to put a little wait in here so the kill can take effect. So we wait 7 seconds, and then we alter the error from a status E to a status C, which will clear it from the queue, and then we send an email to the user. User, your job ran for 30 minutes, it was canceled and cleared from the queue. And you see that here kind of in action. So the job is still active at 10 o'clock. At 10:30, the WAPL job kicks in. Here's where it performs the kill. You'll see that it puts the job into error. And then the last 2 steps is we change the status to a C, which you'll see here. It clears that up nicely. And then here goes your email to the user, letting them know that the job ran for 30 minutes and that the error is cleared from the queue, so no operator action was actually needed for this particular situation. So that was for the list stat. It's probably the most widely used WAPL function that we have in our environment, and as you can see by that, because we use it to control a lot of our distributed workload, it actually makes things a lot more efficient the way it's controlled. So the next function that we're going to talk about really quick is the find command. Dean spoke about being able to find statuses of jobs or find things in the current plan. So in this particular scenario, we're going to make something up here. I made it up. The user wants to find all the jobs with the TS prefix in the current plan that are on wait. I want that information to be sent to me in the email. All I need in this email is the job name, the workstation, and the status of the job. And once you find that information, I want you to know up all the jobs in that list. So this is the code that will be used for this particular scenario. You know, again, what Dean mentioned before is you can create temporary files to be passed down into the WAPL code by creating, a temporary file. So in this case, you'll see, and this file is going to contain the information that we get from the find. So we define a temporary file, as you can see here, and then we're going to pass this file down, you'll see later on, to be put into the email. So we're going to create the temporary work file, like I said, to store the data. We're going to provide the TS prefix in the find command, because that's all we want to look for, all the TS jobs that are on wait status. So you can see here all the job names that start with TS, status of wait, either the current date that you're doing this query, workstation ID if you want to filter for that, and then we're going to set it to an object. Dean spoke about setting whatever you find to objects, and we're going to show that later on here. The object we're going to call is the object's going to be called jobs, and we're going to also write a save list to store the data, and we're going to call that save list TSW list. So TS jobs that are on wait, and that's our TSW list. And then we also want the email to be generated using the work file that gets created from the find command. And then the last thing is the no-op. If you remember the scenario, the user wants all the jobs that are on wait to be no-op so that they don't run when they're scheduled to run. So here's where we set the find command to find the TS jobs. Here's where we set all our variables. And this is what Dean spoke about before about the object names in the current plan. CPOP or CPOP JBN is the object name for the job name. CPOP WSN is for the workstation, and CPOP ST is for the status of the job. So when the find gets all this information, it writes it to a work file, and then the work file is going to have it in this format. It's going to have the workstation ID based on the variables that we define up here. It's going to have the job name, and then it's going to have the status. So once the find gets all the information, it writes to the work file. And then here's the second part of the find command. After we found all the information, here's where we send the email and issue the no-op command. So after all this information is populated, we're going to send an email to the user that all these are the TS jobs that are in wait status, and that after the email is generated, the very last step is to, the very last step is to no-op whatever is in the TWS list. And you can see here the SOE, or I'm sorry, the WAPL in action. It's querying the database. It's finding all the jobs that are in TS status. And then you'll see here the end result is the information that was put to the save list, or was put to the work file, I should say, was in-streamed into the email. And here's what the user would basically see. Here's all your TS jobs that are in wait, and these are the jobs that are going to be no-op. All right, the next section here is for dynamic submission. Again, I mentioned before we use the dynamic submission instead of the traditional every option. I think, like I said before, it creates a self-managing application. Jobs that end in error can have action taken on them immediately with no downtime if it's an application that has to constantly run. It also allows for easier maintenance. If you think about a job that runs every 5 minutes, let's say you had to change the workstation on that job. You'd have to change it for every single interval. At least if you're using dynamic submission, you only change it in the application database once, and then next time it comes in from WAPL, it'll have that change, and it'll continue, putting that change in throughout the day. So here's an example of the dynamic submissions. This is a very simple example. This particular application, we're using the same one. It has an input arrival time of 1310, but we have it to run from 1310 up until 2200 every 10 minutes. And here's the command that will do that. So as soon as the operation is complete, as you'll see in the example here, the WAPL job kicks in, and it puts it in 10 minutes later, as you can see here in the next interval. And again, this is useful for dynamic processing, because if you have an application that runs quite frequently, again, I think this is a more efficient way to only put the application that's going to run at any given time into the queue. The JS start is another function that WAPL allowed us to use, or that we use in our environment, that helped us do some type of processing that we have here. And the situation that we came across is that we have jobs that go into the queue that use the same job name, but each job name would usually have different JCL based on a front-end system or a front-end JCL generated application. So what the JS start allowed us to do was it pre-staged the JCL. Even if we had the 5 jobs with the same job name, each job name would have different JCL based on whatever was inputted in the front-end system. The one thing that you have to make sure you have coded in your WAPL is the EQQ.js PDS. This is going to be the library where the WAPL job is going to pull the JCL from, and it's going to put it into the job and stage it for you in the current plan. So as you can see in the example here, we're going to insert the JCL for operation 001, and we're going to take the member oper 002 from the PDS that we have defined here in the EQQ.js PDS. So make sure that the JS start runs as soon as the application is triggered. I think that's pretty obvious, because as soon as the application comes in the queue, you want to grab the JCL immediately, because sometimes you have an application that runs maybe later on in the day. You want to make sure that JCL is there before the application or the job takes off. So you can see here that you can kind of see it here in action. So the application comes in at 10 a.m., but in this case, it has a special resource, whatever the case may be. I think this particular situation, this doesn't run maybe until later on at night. So the WAPL job will actually run, and remember how we defined it. It's going to pull operation 2, or oper 002 from the PDS. You'll see here that this operation is waiting to run, but it has oper 002 pre-staged already. And I know this is a no-no. I know this will fail. You guys can see it's the different job names, but I just did this for effect. So yeah, this is this is used for couple situations that we have here where we need to pre-stage the JCL. So using WAPL to do that, or WAPL will allow you to do that if you need to. The next section is housekeeping our databases. Again, I mentioned before that if you had to back up your application database, your operator instruction database, the workstation database, it's good to do in case you needed to migrate or if you needed to restore a corrupted database. So in this particular case, we're using the list command to get the information from databases that we're trying to back up. So you see here highlighted, we're listing the workstation database, and we're getting all the workstation names, and we're writing that to a backup file here. As you can see, it puts the out file into batch loader format. And then these extra examples are basically, if you wanted to back up your ETT database or if you wanted to back up your JCO variable database, this is the line of code that you would use. So this is pretty straightforward. Again, it's just good housekeeping to back up your databases in case you had to restore them or whatever the case may be. And you can use the same job to load it. You just have to change the sysint to use whatever the data set name is or for the backup that you have. And the last part, again, as I mentioned before, is the global flexibility. The ability to read in the variables defined in the user field, it allows you to have very minimal generic code in your WAPL libraries. So you can only create a handful of master JCL members, and then you can tailor them specific to each operation with the use of the user fields. And you'll see that here. This is where we set the variables that are going to be read in to the WAPL code. So the items in yellow represent variables to be passed down to the subsequent code, and the items in white represent the user field name or whatever value that you code in each individual operation that is going to be passed down into the variable that you have defined here. And I think that the next screen will show that a little better. So in this case, this is one example of an operation that has several user field names and user field values defined. In this case, we have several user field names here, and again, going back, it coincides with the user field names that we're defining for this particular job. And all these values here are going to get passed into the actual code. And again, this is what allows you to use one generic code for a high number of jobs, is that whatever you defined in your user field name, it's going to translate and it's going to pull that value from the user field. So in this case, we're going to use a list stat that I have an example here with a variable substitution. And as you can see here, the variable substitution I have here is APP #CHCK. The workstation name is variable with job #WSD, and so on and so forth. So this information goes into the jobs user field, and it passes the information down into the code, again, making it generic in a sense, and you can use it throughout all your applications. So this is a basic template of what it would look like based on a code of a 99. In this example, we're going to send an email notification, provide an email body with some information as well, and dynamically add the application with an offset time. So in this example, this is based on a job that fails. So if the list that returns a 99, here's the action I want you to take. I want you to send an email to the users, and I want you to let them know that the job failed and it's running on another interval. Basically, you can see here in the email body. You want to alter the job name from E to C to clear it from the queue, and then you want to add it back in again with an offset times if you wanted to do it for 5 minutes later, 10 minutes later. So in this one command, we're doing 1, 2, 3 different functions based on the status of a 99. And we're using variables in this one particular code that are going to be translated from the user field. Okay, yeah, so that's where it cut off. So yeah, again, with the variable substitution, it just allows for a lot of customization, and it just makes using WAPL in your environment that much more flexible. So that's where I'm going to leave off. So any questions, or if I hand it back to Lisa and Jennifer?
Okay, well, thank you very, very much for that. we'll now open it up for questions. If you would like to ask a question, please do so using the chat window located in the lower right-hand corner of your screen. Okay, we do have a few questions here coming in. All right, the first one, this is from Raymond. Since we are talking about Rex code, then I would guess that WAPL is only on the ZOS side, correct?
Yeah, that is correct. However, you can run it against operations that are being scheduled by IWS for ZOS on distributed boxes. It will manipulate the current plan for those operations, but it only runs on ZOS.
Okay, great. All right, another question from Warren. Mark, first, thanks for an excellent WAPL presentation. When making plays, do you prefer to work with Dean or Odell?
Oh boy,
Being an inside joke there.
If Dean can catch like Odell, maybe it might be a tough conversation. But
all right, Jan asks, hi, is WAPL load mod delivered within the IWS code from release 9.3?
It's not a load module as such. It's compiled Rex, but yes, it is delivered from IWS version 9.3. The Rex code's delivered in the SCQQ MISC library, and it also has a new library called SCQQ WAPL, which contains a lot of definitions that you can reuse yourself.
Okay, great. And I think we have time for at least one or two more. So Thomas asks, is SOE compatible to WAPL? We currently use 8.6 and will be upgrading to 9.3.
Yeah, WAPL simply is SOE with more features. So it's the same engine that was there for SOE, it just does a few more things. So if you've got SOE code, that should work as WAPL code.
Okay, great. Thomas did say thank you. Now, one more question here. What feature of WAPL is of most interest to you?
I think that's for the audience, isn't it, that one?
Ooh, that was actually, yep, you are absolutely correct. All right. We'll give it another minute or so for any other questions that do come in.
Just a little addition to the compatibility question there, by the way. If you install IWS 9.3 on your system, you can actually run WAPL against any of your earlier versions of TWS as well. It is compatible with earlier versions. So you could actually install IWS 9.3, not migrate any of your controllers, so leave them running at the old version and run the 9.3 WAPL code inside your earlier workload. So you could, the person there that talked about running 8.6 could actually put WAPL in now and run it as long as they do a 9.3 install somewhere, but they don't have to migrate. You can actually just use WAPL against an earlier version.
Oh, that's great. Wonderful. All right. Well, all the questions have come in, so thank you both, Dean and Mark, for your time and sharing your knowledge with us today. We'll see if there are any follow-up questions. It will be available on the TUC website. And thank you, ladies and gentlemen, for attending this webinar. Oh, wait, hold on. I had two more questions come in if you guys have another second to answer.
Yep, sure.
Excellent. Okay, Doug says, and WAPL 9.3.0 is supported by the IBM Support Center.
Yes, it is. Fully supported.
Okay, wonderful. And Jan wrote back again, I've seen some examples in some PowerPoint where, okay, EQQYXJCL is executed. Is that a new Rex dataset delivered in 9.3?
It's actually a procedure. It's a JCL procedure that is the procedure that calls WAPL. So from 9.3, when you run EQQ jobs, it will generate that procedure for you, tailored for your environment. But you can also run WAPL as a starter task operation as well. something we've not really touched on this presentation, but you can actually embed your WAPL commands directly in your application, and they run almost instantaneously if you run as a starter task operation. But the EQQ jobs process will create you tailored versions of both the batch JCL and the starter task JCL to run WAPL.
Okay, great. And we do have time for another question. Richard asked, are there any examples of calling WAPL from Rex?
I've not seen anybody actually call WAPL from Rex, simply because WAPL is now so Rex-like, most people write WAPL directly. However, if you go and have a look at, I think there are some samples that come out with WAPL that will show you how you can call the WAPL. The WAPL module is EQQYXTop, and you can pass commands to it using the stack. And I do believe there's a sample somewhere in the sample library that shows you how to do that. This used to be the common way of running things with SOE. You would write what was called an SOE exec, which was Rex calling SOE. But since WAPL became a programming language in its own right, it seemed less likely anybody would do that, so we didn't stress that in the manual, because there was so much in the manual in the first place, it would probably be too much. But there probably is a sample somewhere in there. You just need to do a search to the sample library for anything that references EQQYXTop.
Okay, great. Said, great, thanks. One last question from Jan. Can WAPL be downloaded somewhere to run if we run IWS 9.2?
Technically, no. The only way you can get it is to do an install of 9.3, but you can install 9.3, say, on your sandbox system, and then the only two libraries you then need to lift from that are the SEQQ MISC, the SEQQ WAPL library, and make sure that you've got a copy of the proc that was generated by EQQ jobs. So you get it from the official source, maybe on your sandbox system, and then put that wherever you like in the rest of your system. So you have to order it the proper way, is the only way. But you don't have to upgrade the rest of your system to 9.3.
Okay, great. Thank you again, Dean, for that. Well, thank you, ladies and gentlemen, for attending today's webinar. As you exit the webcast, please take a few moments to fill out your post-event survey and help us improve our future events. We truly appreciate your feedback. This concludes today's conference, and have a fantastic day.